Welcome, y'all. Welcome to geometry class. Good afternoon, I guess this is. I just want to go over this law of cosines with you because not real hard lesson, but just hard enough that I thought I'd like to go over it with you. We learned the law of sines a few weeks ago. Interestingly, advanced math learned it before you. They haven't learned law of cosines yet, but it's coming up fairly soon. So you guys should have learned this back in advanced math. But of course, that was a couple of years ago, and so I just wanted to go over it with you. So in solving triangles, we said in that earlier lesson that you can solve any triangle if you know three things, including at least one side. And we use the law of sines. And the law of sines works in a lot of cases. As long as you have the right things to go into it, you need two sides and an angle, or matching sides and angles. That's the key. So if that doesn't work, then we can use the law of cosines. Okay, so law of sines is the easier one. At least that's what they assume. And so law of sines is the easier one. That's one they taught first. But if that doesn't work, then you use the law of cosines. There actually might be some situations where you would prefer the law of cosines instead of sines, and that would be fine. Okay, the law of cosines looks like this. A squared equals b squared plus c squared minus 2bc cosine A. Or b squared equals a squared plus c squared minus 2ac cosine B. Or c squared equals a squared plus b squared minus 2ab cosine C. Okay? Now, this is a generalized Pythagorean theorem. If you'll notice, the first part of each one is a squared equals b squared plus c squared. That is the way a right triangle would look. That's a Pythagorean theorem. Cosine of A, if A were 90 degrees, that would be 0, and then that whole term disappears. So if you have a right triangle if you have a right triangle across from the first letter A, B, A in this case, I'll just use the first one. If angle A is 90 degrees, you get Pythagorean theorem. So basically what we have here is Pythagorean theorem with a correction for the fact that the angle's not 90 degrees. Okay? You could actually use this in right triangles for the odd side, like for non-hypotenuse side. I don't know why you would, but you could. And so this is actually a broader equation. The law of cosines works for any triangle. Pythagorean theorem only works for a 90-degree angle across from the one side. Okay, so let's do that. So that's it. It's plug and chug from that point forward, okay? So let's look at an application of this, okay? So here we have a triangle with two sides and an angle. And we're going to use the a squared equals b squared plus c squared minus 2bc cosine A, because you'll notice that's what we have. We have side B, which is 3, side C, which is 10, and angle A, which is 20 degrees. So we plug it in. A squared equals 3 squared plus 10 squared minus 2 times 3 times 10 cosine of 20, which is 9 plus 100 is 109 minus 56.38. Plug that through your calculator to get that. And subtract, get the square root, and you get side A is 7.25 units. There you are. That's it. And then you can use the law of sines to find another angle, because now we have A and angle A. And then you could find, and we have both sides B and C, so we can find angles B and C. And to get the third angle, of course, just subtract from 180. Law of cosines is usually used first, then they switch to law of sines. Again, you could technically continue using law of cosines, but they consider law of sines easier. Okay, so let's try this one. This one's a little different because here we have all three sides. We have no angles, but we have three sides. So we plug in our three sides, and I'm going to go ahead and just the way we had this set up. This is, I guess this is the way it's set up. So side A is 8, side B is 3, side C is 10. So 8 squared equals 3 squared plus 10 squared minus 2 times 3 times 10 cosine A. Slightly different algebra here, but it's well within you guys' capabilities. 64 equals 109 minus 60 cosine A. Subtract 109 from both sides. Divide both sides by negative 60. Divide, you get 0.75 as the cosine of A. Inverse cosine, and you get angle A. And then use the law of sines for the other angle, and then subtract from 180 for the third angle. That's it. It's really not a bad. It's not only not a bad thing. It's very much plug and chug, but it is a kind of a cool concept, and it's just a little strange. So I wanted to go over it with you. Okay, well, have a good time in your lesson today.